Jai Hind everyone, my name is Mukulit Goel. I am assistant professor in Department of MCA at Akgec Engineering College, Ghaziabad. Today I am presenting a topic on memory organization and cache memory from the subject computer organization and architecture for subject code BMC 105 for MCA first year students. So the content of my slide is what is memory, memory hierarchy, memory organizations, type of memory organizations and cache memory in detail. So I will start from what is memory. So memory is a circuit that allows data to be stored and retrieved when required. Basically memory is used in two ways, for the storage or you can say for the storage and for the backup, but it is of two types, which is volatile and non-volatile. So the volatile means in which the data will be lost when you switch off or shut down your device, and secondary memory is where the data is stored and cannot be deleted unless your interference. And when the memory unit, and it's the part of the memory unit, and when memory unit communicates directly with the CPU, is known as main memory. And when we need the storage for devices for storing our data, then it is an auxiliary memory. So main memory, in component terms, the main memory can be said as RAM, and the auxiliary memory or secondary memory can be said as a ROM. RAM stands for random access memory and ROM stands for read only memory. So it is the classification of memory, that where it is stored, how it is accessed, what is the performance, physical type, physical characteristics, capacity and unit of transfer. So when the location is CPU, the memory method is sequential access, performance is access time, the type is of semiconductor, physical characteristics and volatile and non-volatile, which I have already told. Volatile means RAM and non-volatile means ROM. The capacity is in the form of word or size, and the unit of transfer is word. When we talk about the internal memory, it is direct accessible. It works on the cycle time. Its physical type is magnetic surface, like we have seen at earlier times, which is magnetic disk, magnetic tape or CD-ROM. And these can be of two types, which is erasable and non-erasable, and it consists a number of words, and each block constitutes of these number of words. And the last is external memory, which is random access, and its performance, it depends on transfer rate. External memory is like we have using USB drive, we call it pen drive. So these are the examples of external memory. So what is memory address? So the main thing regarding the memory is, when we send any instruction, how our system or memory identify that instruction. So for that, there is a requirement of memory address, and it is an identifier for a memory location at which a computer program or hardware device can store a piece of information for lateral retrieval. So for the lateral retrieval of information, the memory address is very much required. Because of that address, that instruction is identified. These address is of two types. One is absolute address and another was relative address. In absolute address, memory address uniquely identified the location in memory, and in relatively address, it is not unique and specify the location in relation of some other location. Means some other location means the reference of some other location. What is memory hierarchy? Memory hierarchy is the enhancement to organize the memory such that the minimized access time will be at the top of the hierarchy, and the access time and also the size, the minimum size and the maximum access time. Minimum access time is at the top of the stack, and the memory hierarchy, which is the larger in physical in size, and take the maximum access time will be at the lower of the hierarchy, like this. So the what we are seeing here is that access time is also increasing and capacity is also increasing. So the minimum access time or the fastest memory is CPU register, and the maximum time taken memory is magnetic tape. So it is, if I start from the below, then it starts from the magnetic tape and goes up to the CPU register. So magnetic tape, optical disk, magnetic disk, main memory, cache memory and CPU register. It is the hierarchy of memory on the basis of access timing, increasing access time and the increasing capacity. This increasing capacity might be not in GB but also in the physical size. The categories of RAM, there are two types of primary memory. One is RAM and ROM. So the RAM is random access memory and the ROM is read-only memory. The ROM is of two type, bipolar and MOS, and RAM is of magnetic core and semiconductor. So the device, the RAM which we are currently using is of semiconductor. Memory organization. In the internal structure of memory, there are RAM and ROM, which is made up of a memory cells, and these cells contain the memory in the form of bit. Then also these are the multi-dimensional arrays of rows and column in which a bit and the word is stored. So each column stores a bit and each row stores the word. There is a two type of organization, one is RAM and ROM, and these RAM is static and consists of flip-flops which stores binary data, and the information is volatile as I have told earlier, and it remains valid as long as the device is powered on. And it is the structure which we have 8-bit data bus. The 8-bit data bus have the 7 address lines. From where these 7 address lines comes, the 7 address lines comes in the form of 2 raised to the power n. In the form of 2 raised to the power n. This comes in the form of 2 raised to the power n. So when we are saying 128, so 128 is equal to 2 raised to the power 7. So we are using 7-bit address line. Okay. So this can be calculated like this, and the chip select is 1 and 2. Chip select is dependent on how many are there address lines and how many chips are there. So here in this diagram we are using 2, which is chip select 1 and chip select 2. The structure of ROM. In ROM, in the structure of RAM, one extra thing is we have read and write operation. The read and write operation is in the RAM, but in ROM there is no read and write operation, because in this ROM we only stores the information, and here we are using 9-bit address. Why? Because 512 is equal to 2 raised to the power 9. So we have using 9-bit address because the address lines are denoted by 2 raised to the power n. So it is the structure of memory, how these memory are connected to the CPU. There is a CPU which contains the data bus, and this data bus is connected to the RAM or ROM, in which there is a address lines, read and write operations, and chip select 1 and 2. So in address bus there is a 17 bits of address bus. There is one decoder which is connected to the chip select. There is a address bus which is connected with the all these chips. This is the RAM chips, and it is divided from 1 to 16. So it is a 16-bit address bus. So when in this connection, the CPU connects the ROM and ROM through the data and address bus. The 7 bits of the address bus are connected directly to the each RAM chip. So 7 bits are connected directly to the each RAM chip, and 8 and 9 lines are connected to the inputs through the 2x4 decoder, whose outputs are connected to the chip select 1, and the read and write outputs from the CPU are connected to the inputs of each RAM chip. To distinguish between the RAM and ROM, the line 10 is used. The line 10 is the ROM chip and the address bus lines are 1 to 9. Okay, the RAM can transfer information in both directions where RAM has only output capabilities. Okay, so the RAM will connected to have the both directions, while ROM have only one direction which have only output capabilities. Now there is a memory organization, types of memory organization. There are two types of memory organization, one is 2D and another is 2.5D. So in 2D organization is divided into the form of rows and column, the matrix of rows and columns, and each row contains the word and it is in the memory. There is a one decoder and the decoder is the combinational circuit that contains input lines and 2 raised to the power n output lines, and one of the output lines selects the row by the address contained in the memory address register, like this. So it is a 2D structure of memory organization. It is a matrix of rows and columns where what we can see, there is a one decoder, and these decoder in this decoder there are the address lines for rows which is selected from the memory address register. Each block or matrix contains the word, and these words are in the form of 2 raised to the power n, which I already told you. If there are the 512 into 8 ROM, then the address line will be 9. So it depends on 2 raised to the power n word. There is a select line through which the read and write operation is performed, and there is a common output circuit which is denoted by the column. So each column is an output input circuit. Next organization is 2.5D organization. In this there is a two decoders. One is represented as a column and the another decoder is used as the represented in a row, and the address from the memory address register goes as the decoder input, and the decoder will select the respective cell through the bit line, and then the data from the location will be read through the bit line and will be written at that memory location. So you can see in this structure that there is a two decoders, one is for selection of rows and the another is the selection for column. So the bit in and the bit out is dependent on the column decoder, and the address or address register or the address lines are dependent on the row decoder. So the row decoder represents the address lines and the column decoder represents the input and output. So if there is if the address which is stored in the RAM and it is found, then on the basis of that the decoder of the column constitute the read operation and the write operation. The read and write operation, now it comes the read and write operations. If the select line is in the reading mode, then the word or bit which is represented by the memory address register will be available to the data lines and it will get read. If the select line is in write mode, then the memory data register will be sent to the respective cell which is addressed by the memory address register, and the data is written on that particular node. With the help of the select line, the desired data is selected and the input and output operations are executed on them. Next is the cache memory. It is the another type of memory which is placed between the CPU and the main memory, and it is the smallest size of memory which increases the performance, and it transfers the data from the CPU to the, it helps in the transfers of data from the CPU to the main memory. And there is a two type of transfers which is executed through cache. One is word transfer when it is doing from the CPU to cache, and another is block transfer when the cache is transferring to the main memory or main memory transferring the data to the cache memory. So there is a two type of concept in cache memory. When the any instruction is executed and CPU finds the address of that instruction in the cache memory in the form of tag, then it is called as hit, and if the block or the required block is does not is in the cache, then it is called as a miss. So there comes the principle of locality, and it is the principle of locality is based on the likely to find the next reference data and instruction in the cache memory that can result in bringing the whole block rather than required word. So the cache memory the size of the cache memory is into 2 raised to the power n, where n represents the address line, and the main memory is divided into block, and each block contains the word which is represented by the, and the block is represented by the 2 raised to the power n divided by the k words which is in the each block. So at any time the cache will hold some block which are involved in the processing at that time, and the number of cache lines is much less than the number of blocks. So each line have the tag to indicate the block it holds. Basically tag is the unique address which is attached with our instruction in the cache memory. Like you can see here in the diagram of cache memory, the structure of cache memory and the main memory. The cache memory contains the block, and each block uses some bits for tag. Depending on the structure and the mapping of the cache memory, the tag size is varied. Normally from the tag size dependent on the mapping of the cache memory to the main memory, and the main memory contains the block, and each block contains the word which are required for the address reference. So the cache memory do the operations basis on the request from the CPU. CPU checks the cache for the data. If it is present in the cache memory, then it has been executed. If it is not present in the cache memory, then the read block is required from main memory to cache, and through that read operation, the data or instruction from the main memory is transferred to the cache memory, and then from the cache memory it is transferred to CPU, and the CPU includes the tag to identify which block of the main memory is in the cache slot. So the tag is the unique identifier for that word. It is the flow chart of the cache read operation. Like I have said that we receive the address from CPU, and if that address is in the cache, then we fetch that word and the instruction is executed. But if that word is that block or that word is not in the cache memory, then we access the main memory for searching of that receiving address which contains in the block, and when we after that we allocate that cache line to the main memory, and the instruction loaded in the main memory block from main memory block to cache line, and then it is delivered to the CPU. It is the typical cache organization in which we are showing the control and address. So when we are searching for any instruction, then we are talking in the terms of address. When we find any data, then we are talking in the terms of data. So from the processor to cache and to the memory, we are transferring the address, and the cache is controlling this procedure of transferring the address, because that address is also contained in the cache in the form of block, and it's same in the case of data. So all these are connected with the system bus, and the system bus contain all the 3 type of buses, which is address bus, data bus and memory bus. With this I am completing my lecture. Thank you very much.